So good day everybody. So welcome to Noble Team YouTube channel, and my name is Noble CEO. I'm founder of Noble Team. So if you are new to this channel, do well to subscribe to our YouTube channel. And in today's class, we are going to be looking into relative humidity calculations, okay? And this is under quantity of heat energy. Quantity of what? Heat energy. So I will implore you to do what? To get your headphone or your earpiece to avoid anything like distraction. So basically what we are going to be doing in this tutorial video is calculation aspect. We are not going to be doing the theoretical aspect, okay? We are going to focus more on the calculation aspect. So now, before we move into the calculation aspect, we need to know some certain things under relative humidity, which is what? RH. Now, when you talk about relative humidity is being expressed in percentage, okay? Write it down, because I don't have enough space to write, because I'm going to use this and this to do what? To solve some questions. And I will implore you, after solving this question, you go and practice more. That is how to learn. So relative humidity is being expressed in percentage. You know, percentage is 100 now. So now we have important formulas we need to take note in relative humidity. So we have the first one, RH, which is the actual vapor pressure. This piece what? Pressure, okay? Vapor pressure divided by saturated vapor pressure, then times what? 100 times 100%, okay? Times 100%. So this is pressure, so you take note of it. Now the second formula is when we have that RH is equal to actual mass of water vapor. This is what? Vapor, okay? Then divided by maximum possible mass. Maximum possible mass times 100%. So we have the third formula, which is RH is equal to actual vapor density. This is density. Then divided by saturated vapor density times 100%. Okay? Now, I want you to take note of this, that relative humidity is being measured with an instrument called hygrometer. Let me write this out. It's being measured with an instrument called what? Hygrometer. Hygrometer. So you take note of it. Okay? Now, I want us to solve questions, real exam questions that you might see in your exam. So this video is not only for people writing JAM. This video is for JAM students, YX students, NECO students, and even students preparing to write post-UTME exam, because this video will help you a lot, okay? Now, let's solve some certain questions. And do well to do what? Do well to pay maximum attention, get your calculator, okay? Now, the question will appear on your screen. So all I implore you to do is to do what? Pay maximum attention. Now let's start by solving question 1. So question 1 says the table, you will see the table on your screen. So shows the saturation vapor pressure, which is SVP. Saturation vapor pressure, which is SVP, against temperature in a certain town. If the vapor pressure in this town is at 20 degrees Celsius, is 10 millimeter mercury, then what is the relative humidity? Question 1. We are being asked to get relative humidity. And coming to the table, now this is how to solve this kind of a question, okay? The question says that in this town at 20 degrees Celsius. Now go to that table and trace 20 degrees Celsius. And 20 degrees Celsius there is what? 17.5 millimeter mercury, okay? Now we are being asked to get the relative humidity. Now which formula are we going to be using? This, the actual divided by the what? The saturated vapor pressure, okay? Now we now have that RH is now equal to, now which one is the actual one? So the actual one was given in the question, which is what? 10, which is 10 millimeter mercury, divided by the saturated vapor pressure. Now the saturated vapor pressure is from the table. Now trace that 20 degrees Celsius. At temperature 20, you have that your SVP is what? 17.5 degrees Celsius. 17.5 millimeter mercury, sorry. 17.50 millimeter mercury times 100. All right, so now let's multiply to have our final answer fast. So you have 10 divided by 17.5, okay, times 100 times 100. So you have your answer to be what? 57.1%. 57.1%. And this is your final answer. Remember, relative humidity is being expressed in percentage. Do you understand? So it basically means that relative humidity does not have anything like what? Units. Do you know why it doesn't have a unit? This is being expressed in millimeter mercury, and this is being expressed in millimeter mercury. Once it divides, it cancels everything out. So it is what? Unitless. Okay? So when something is unitless, it basically means it is what? Dimensionless. Okay? Now let's look into the question to know which option is correct. So option D is correct. Okay? 57.1, or we can say 57.0 is still the same thing. Okay? Now let's solve question 2. Let's solve question 2. Pay maximum attention. Now question 2 says this. The question will also be on your screen. The temperature of the air is 25 degrees Celsius. Now I want you to pay maximum attention here. When solving relative humidity, you don't have any business with temperature. Okay, you don't have any business with temperature. So go through this formula. You see that I did not mention anything like temperature in our formula. Okay, all we see here is just density, mass, and pressure. So you don't have any business with what? Temperature. When it comes to the calculation aspect, this is the trick there. I'm still gonna release some tricks, but when we move on, solve up to 5 questions and I'll give you the trick. So ensure you follow this video to the end. So the temperature of the air is 25 degrees Celsius, and the SVP of water at that temperature is what? 31.67 kilopascal. 31.67 kilopascal. Then the partial pressure of the water vapor in air is 18.78 kilopascal. What is the relative humidity? Okay, what is the relative humidity? So we have that RH is now equal to our actual one here is what? 18.78. 18.78 divided by our SVP is what? 31.67 times 100. So divide. Once you do your substitution and do your calculation, you get the final answer. All right, so let's do 18.78 divided by 31.67 times 100. So you have it to be what? 59.3. okay, 59.3%. And this is your final answer. Now let's move into option to know which option is correct. Option D. Now some of you might be wondering why I'm using my calculator phone to do, because if you want to practice, for some of us that are about to write JAMB exam, your calculator phone will help you, because your calculator phone is what you are going to expect in your JAMB exam. So you using scientific calculator to calculate physics, to practice to prepare for your JAMB exam, do not make that mistake of using scientific calculator, because it's not going to help you. Once you master your calculator, your phone calculator is going to help you a lot. Okay, so that is why I'm making use of my phone. So it's not that I don't have the scientific, I have the scientific, but using this, we do what is going to help you to calculate facts, and also is also going to be what you are going to expect in the real exam. For some of us that are going to enter, when you enter into higher institution, okay, you are going to still meet CBT exam, and CBT exam you don't have any business with calculator. So let's solve question 3. Now question 3 says that if the partial pressure of a water vapor at 26 and 27 degrees Celsius is 18 millimeter mercury, and the saturated vapor pressure of the atmosphere at the same temperature is 24 millimeter mercury, then the relative humidity at this temperature is what? Still the same thing. Okay, when we solve out to question 5, I'm going to be giving you some tricks. Okay, so make sure you follow this video to the end. The actual one was what? 18, and we have the SVP is what? SVP is 224 times 100. So divide. Let's divide to have our final answer. Okay, let's divide. So 18 divided by 24. 18 divided by 24, we have it to be 0.7 times 100, which is 75%. And this is your final answer. So question 4. So which option is correct? So we have option B to be correct. Now question 4. Question 4 says that on a certain day, the average air temperature was 35 degrees Celsius and the dew point was 10 degrees Celsius if the SVP of water vapor was 18.4 millimeter mercury at 35 degrees Celsius and 11.2 millimeter mercury at 10 degrees Celsius, find the percentage of the relative humidity. Okay, so we have that ROH is now equal to, our actual one was what? Our actual one was 11.2, okay, and the SVP was 18.4 times 100. So divide and have your final answer. Okay, 11.2 divided by 18.4 times 100. So you have it to be what? 60.9%. And this is your final answer. Okay, so we have that option C is correct. Now question 5, let me reveal the secret. Okay, now let me just read out the question before I release the secret. So it says this: the vapor pressure of air at 20 degrees Celsius is found to be 12 millimeter mercury on a particular day. Then find the relative humidity if the saturation vapor pressure of the water at 20 degrees Celsius is 17.5 millimeter mercury. Now, for you to be able to solve this kind of question very fast, you need to apply sense, because in JAMB exam, you don't need to be wasting a lot of time. Okay, you don't need to waste a lot of time. Now, in this particular aspect, if you want to solve this kind of a question, okay, and you want to identify the actual vapor pressure and the saturated vapor pressure, or the numerator of this or the denominator of it easily. Now, listen. In solving relative humidity, the numerator, okay, is always smaller than the denominator. This is the secret. This is the numerator, okay, and this is the denominator. So the numerator is always smaller than the denominator. So what am I trying to say? That the numerator can be 10 and the denominator can be 20. This is it. So it is impossible. It is not possible. Let me use it. It is not possible for the denominator to be bigger than it is not possible for the denominator to be smaller than the numerator. Okay, so you cannot expect something like 20 over 10. It's not possible since you are multiplied by 100. Do you understand? Now let me just show you something. Okay, now in this question, for you to understand what I'm trying to say, we have that our SVP here is what? 17.5 and our actual was 12. So our numerator is what? 12 and our denominator is what? 17.5. Do you understand what I'm trying to say? Since you are multiplying by 100. Now let's solve something. I want you to understand better of this trick. For some of us that don't understand, let me explain it. Now 12 divided by 17.5 times 100. Okay, it's giving us 68.6. 68.6%. Okay, now let me use my red marker. So I want you to understand something. Okay, remember I said that the numerator, this is the numerator, is always smaller than the numerator. This is the denominator. The numerator is always smaller than the what? Denominator. So it basically means that the denominator is more higher than the numerator. So now, for example, I have this guy. Let me just use this guy again. Okay, is equal to, imagine that, okay, I have 17.5 divided by 12 times 100. So I want you to do something I want us to examine something, okay, so you can understand fully properly of what I just explained. That 17.5 divided by 12, okay, and times 100, will give us what? 145.8%. Now, the 145.8% exists. Impossible. It doesn't exist because percentage is over 100. So anything that you are solving for percentage and is above 100, just know that that thing that you are solving is incorrect. Okay? So that is why I explained that the numerator is always smaller than the denominator. So I want you to solve this question 5. So it basically means that option in number 5, option what is correct? Option B is correct since they approximated to what? A whole number. So when they approximated it was 69%. Okay? So now I want you to solve question 6 for me. So the question will be on your screen. So ensure you solve it for me. Okay? I hope you have solved it. Now let's solve together. Question 6. Question 6. Now the question says the mass of water vapor in a given volume of air is 0.05 gram at 20 degrees Celsius. While the mass of the water vapor required to saturate it at the same temperature is 0.15 gram. Calculate the relative humidity of the air. Calculate the relative humidity of the air. Okay? Still using that same method, that RH is equals what? Now, which number is small? 0.05, right? So it's going to be a numerator. Divided by, our denominator is what? 0.15. Okay? Times 100. Now multiply. 0.05 times 0.05 divided by 0.15, which is going to give us 0.3 times 100. Okay, it's giving us 33%, and this is your final answer. Okay, I hope you got it right. Yes, if you got it right, comment in the box I got it right. Okay, so 33, or we can also say 33.33%. So, and option B is correct. So now let's solve another question. So another question. So it will also appear on your screen. Question 7. So question 7 says, on a particular hot day, the temperature is 40 degrees Celsius and the partial pressure of the water vapor in air is 38.8 milliliter mercury. What is the relative humidity? Okay, we have been asked to get what is the relative humidity. Now, how can you be able to get your SVP? Okay, the SVP of the water. The SVP of the water. So how can you be able to get it? Now, remember, they say that the temperature is 40 degrees Celsius. Now, from that 40 degrees Celsius, trace it on that table where what is the SVP of that 40 temperature. Okay, now when you trace it, you see the question on your screen, and it's giving you what? 55.3. Okay, it's giving us what? 55.3. Let me use here. So we have that RH is equal to, our actual one was what? 38.8. 38.8 divided by what? 55.3. 55.3 times 100. And divide and give me the final answer. Fast. Okay, 38.8 divided by 55.3 times 100. So you have it to be what? 70.1%. Okay, and option B is correct. So if you approximate, you have what is equal to 70%. And this is the final answer. So we have solved 7 questions on relative humidity, and I think we are going to be stopping here. So all I implore you to do is make sure you go and practice more questions. Do well to practice more. Okay, so if you enjoyed this video, do well to give us a subscribe. Do well to subscribe to this our YouTube channel by clicking the subscribe button, and like this video. Share it out to your friends. Okay, share it out to your friends so they can benefit. So I still remain Nobu, CEO and founder of Nobu Team. So see you in the next video. Bye.